good afternoon. Thanks for sticking around. As Katie said, my name is David Bianco. I work for Target. So if you don't know, if you're not from the United States maybe, Target is a major retail outlet here in the United States. And so we have this thing called the peak retail season, which we just went through. It's basically the day after Thanksgiving here in the US, so the end of November, all the way up through and including Christmas Eve, peak retail season. And I tell you this because last year, my boss likes to get ahead of things. So around in May, he comes to me and he says, David, it's time to get started getting ready for peak. I have not been in the retail industry that long, but I know usually in May you do not start preparing for things in November. But he had a really good reason. He said, specifically, I would like to know more about our CTI information that we've collected. I want to know if the Intel products that we're putting out are appropriate to support our detection and incident response requirements for our major identified threat actors in next peak season. So the idea is he asked me early, so I would have a few months to work on the project and do the evaluation. They could have some time to kind of digest the results of the analysis, and then still some time to help put things back on track if something needed to be corrected, right? So it was good that he gave me all this extra time because I kind of needed it. So getting ready for peak, yeah, I'm there for that. I want that too. But I didn't really know what that meant, and neither did he, and it turns out that's why he gave it to me, because he didn't know how to do it either. So I guess the first thing that I thought of is, okay, I don't really know how to approach this problem, so I'm going to break it down, like typical computer science and problem-solving kind of strategy. I'm going to break it down into problems, and maybe I'll get some ideas, right? So the action items that I came up with. First one was, first of all, obviously, he wants to know about our priority threat actors. I have to figure out what our priority threat actors are. Fortunately, we have a CTI team that does this for me, so this was the dead easy. I just kind of went over and asked them. They said, I have this list. Let me do a review and see what we think that our priority threat actor list is going to change maybe by the time of peak. So they kind of reviewed that for me and provided me a list. So great. I'm a part of the way there. The next part, though, is figuring out what we know about each of those threat actors. And when I'm talking in this presentation, by the way, I'm going to talk about the outputs of our Intel process. So not raw data, but the various different types of Intel outputs, the IOCs that have gone through the entire process. We heard people talking, basically pooping on IOCs earlier this morning and this afternoon, right? But we're talking about the ones that have gone through the whole process, and these are the ones that we actually consider valuable for whatever reasons. And also our extracted analysis and summaries of adversary behaviors and things like that. So these are things that have already gone through the Intel process. So not raw data, but processed intelligence products. So I had to figure out what was available. And then I had to figure out what was really the meat of this is, now that I know my targets, I have the data about those threat actors, how do I come up with an evaluation that can tell us the answer to the question, are we prepared? And then I actually have to do that. Well, okay, 3 of these things were not too bad. Item number 2 was a little bit tricky, and we'll talk about that. But the first one was done for me, basically, by another team. All I had to do was ask. And I figured by the time I got to the 4th bullet, doing the analysis, once I figured out what I wanted to do, would be easy. I was a little bit wrong and a little bit right. Remember I told you all these things were already processed. The inputs to mine were processed intelligence reports and and other products, right? So you would think that if we'd already done it, everything would be so easy. This was the kind of the first phase where I had to do some thinking, and I will like to give a shout out to my teammate here, Jason Lynch, also at Target, who helped me with the data collection part a lot. Because I'm actually not on the CTI team, so their process is about where they store things and how they, what databases they put them in, or how to find the reports and things were a little bit opaque to me at first. And I'm not on the detection team, the consumer of these, most of these reports. So where the detection team goes to get their information, also a little bit opaque to me. But Jason does a little bit of both of those. Like, it's his job to know where that stuff is so they can create the detection engineering around the intel that we've provided. And he helped me a lot understand how to get all this data. So big shout out to him. If this ever hits the YouTube, he'll be really surprised. Data collection, I looked at it as two big buckets of different types of data. So first we have the kind of traditional IOCs, the facts that we know, right? Hashes, IPs, domains, tool marks, anything like that. Our process, first of all, was to find where those were, because we actually had multiple databases for different intel pieces, depending on what the actual use of it was, and depending on which part of the detection engineering team's process it meshed with. So I had to find out where all those things were and basically do a big data dump, which sounds easy. It was easy for me because Jason did it. But I mean, he had to figure out where that was, but he also had to figure out, we had a kind of tagging scheme that was a little bit inconsistent, where we tagged some things with malware names of the families, and some things with the threat actors. And if you knew that the malware was the threat actor because you dealt with this all the time, you would know that this was one of their tools that they used. It was probably associated with them. Okay, you could do that. But if you just come to it and say, I have threat actor X and I want to dump everything you know about threat actor X, our tooling actually did not support that. So we had some gyrations to jump through there. But we were able to eventually dump out all the IOC data from our various tips and databases and stuff. And then I had to clean up this data. It was very dirty. Different places that we recorded the data recorded different pieces or different attributes for that data. And in some cases where it looked like they recorded the same attribute, it wasn't the same attribute. For example, almost everything had a timestamp associated with it. I'll show you an example later on where that wasn't true, but almost everything had a timestamp. But in some cases, the database was showing the timestamp that was added to the database, and sometimes it was showing the last update time or the time it was last known to be current intel, and it wasn't always kind of obvious just by looking at the column names. So we had to really put some work in to understand what it is those databases were telling us, and clean all that up, and put it in consistent formats. Because if one database stores things by, seconds since the Unix epoch, and the other stores it as a YYYYMMDD kind of format, we need to make them be the same so that we can look at them and compare them correctly. So there's a lot of cleaning and data normalization going on. I was pretty much prepared for this, though, because I do a lot of data analysis tasks, and most data analysis tasks, the first 80% of the work is this: finding the data, cleaning it up, and normalizing it, getting it prepared to do the actual analysis. So that's one type. The other type is we had all these behaviors of the TTPs. Where the IOCs were usually in databases where you can search for them, our behaviors were usually in ASCII documents in a wiki. So when Jason says, I can dump all these, I'll figure out how to deal with the tagging and whatever, and we'll just dump them all out, I was like, great. I I'm going to read these 100 or so documents and just manually extract everything into our favorite Intel tracking tool, Excel. On the other hand, you know, it's a lot of work, and I had to spend some time actually figuring out that I had all the documents and then read them all and do kind of like what Katie was talking about earlier today, where she showed you how she mapped English text into attack behaviors. That's exactly what I did. In fact, we mapped them into attack behaviors, but I also took some of the other pieces as well. And then I had these two buckets of cleaned and normalized data, and I had to merge them into one big bucket and decide if there were any duplicates, and if there were, which one to keep, or how to merge them, the two duplicates into one, and deduplicate all that data. And now, but finally now, I was able to do some visualizations, which we'll talk about in this presentation. But this was my process here. Find all the data, spend most of my time writing Python code to make it so that I could do the one box at the end. So thinking back to my action items, okay, I've got the data. Now I have to figure out what I'm really interested in doing with that data. How do I evaluate it? Well, we had a number of things that we wanted to know. I kind of extrapolated from my original request, and I made up my own list of questions, like, do we know what the adversary's repeated behaviors are? For our IOCs, or really even for our behaviors, how volatile is that information? Is it something that is likely to change next week, or is it something that we're likely to be good on by peak retail season? We mapped everything to an attack lifecycle. So if you think of the attack lifecycle like the cyber kill chain or the MITRE ATT&CK framework, where Katie keeps telling me I'm doing it wrong, which is like true. In which lifecycle phases do we know a lot about the adversary's potential behaviors and IOCs, and which don't we know very much? Those are the places that they could potentially operate in our environment without us finding them easily. Is our intel fresh, but not too fresh, because we would like to not only know what they did last week, but we would like to be able to track patterns of behavior over time for tendencies and tracking changes in behavior that might allow us to project farther into the future how their tendencies might change or adapt. So do we have, you know, not only just enough intel, but with the timing of this intel? Is it good? Is it fresh? Is it old? Is it a good mixture? And finally, with all these, how do we concentrate or improve our detection, or excuse me, our collection, so that we could properly support the detection efforts? Notice nowhere in here did I say, are we detecting these things? It's all the CTI piece. Is it able to support detection? Detection being, you know, a different question. Looking at all these, I decided that I wanted to take a look at the data that we had collected through the lens of two different models. And so the first one is the attack lifecycle. So again, Katie made the point in her and Brian's presentation earlier that the behaviors in the attack lifecycle are not ordered, but then they have this graph, which is a kind of extension, I think, of the Lockheed Martin cyber kill chain. And it seems to have an inherent order, right? So we were pretty much integrating as much as we can with the attack framework. So I chose the attack framework's lifecycle model, but you could easily, without changing the analysis really at all, integrate your own favorite. So if you want to use the Lockheed Martin cyber kill chain, you could. If you had a different one that you've developed or someone else's that you liked, you could too use that as easily. The idea, though, is that it has the key criteria is it has a progression where typically, not always, but typically the things on the left side of the model, starting with recon, are earlier in the phase than the things to the right. And typically also that would mean that the things to the right are more critical if they happen to you, because the attacker is farther along in his life cycle. So the first thing I did was I just kind of said, I would like to know how much we have about a specific adversary, not all adversaries together, but a specific adversary in each of the life cycle phases. So I just did a simple heat map. Now, really, I hate when somebody comes up to me and says, we've got 1 million indicators, buddy. We're good. Because just that number of what you have in your tip or your Excel or whatever you're using is useless. But when you pair a number of indicators with some extra pieces of context, in this case, a specific threat actor, and map it to a phase in an attack lifecycle or something, you could conceivably start to get some value out of simple counting, which is pretty much what a heat map is. I can look at this heat map and tell you that most of our CTI collection has been around the delivery, the exploit, and the command and control phases of this adversary. Remember, this is only one specific adversary's data that we're looking at. And we don't really know that much about how they do recon or weaponization to deliver those things to us. And once they've delivered and established command and control, we don't really know that much about what they do later on in the cycle. Which is important because specifically for these three, delivery, exploit, and command and control, they often happen within seconds or even less time. So it would not be it may be technically incorrect, but it would be defensible to say this is all one event. From the time we get the exploit and it executes and calls back out to its command and control server, and the adversary is actually able to do something with it, if it's like a 5-second window, you might as well consider it one event. And if you didn't detect it then, you probably lost your chance, right? So we have some gaps here. The other model that I wanted to look at all this data with was something that I put out a few years ago that we called the Pyramid of Pain, right? If you're not familiar with the Pyramid of Pain, it basically says these are some common, I think the most common types of threat intel data that you might encounter for detection and incident response purposes, not including things like campaign attribution or anything like that, for detection and response purposes. So you can have a hash value, IP addresses, domain names, network or host artifacts, tool marks or tools, and then you can have the behaviors at the top. And the farther you go up the top, the harder it is for the adversaries to change that indicator and swap it out for something else. Like if you can detect and respond to that thing that you know quickly enough to negate its value to the adversary, they have to replace it with something else. And some things are super simple. A hash value on the one extreme, they can just add a null byte or something to the end of, they don't even really have to recompile their malware. They can just edit a string with a hex editor, and it's still the same malware, but you just change the hash value entirely, right? In mid-level, the network or host artifacts are the tool marks of running the tools. They may be a registry key or a file name or a way that they construct their URLs. Many times, they have to just change a format string or something like that in their code, but at least they have to recompile it and maybe retest it and redistribute it to change it. And then if you go to the top, that's their behaviors, is the way that they've learned to operate, and changing that is really hard. So what we did is similar to the previous example. I kind of looked at how many we have, how many indicators that we have at each of the pyramid levels. And I say, well, you know, we're actually doing pretty good. We have a large amount of hashes. We have some IPs and domains and artifacts. We even have a fair amount of TTPs. We don't know that much about their exact tool set, though, which is unusual because we have a lot of hashes, presumably hashes of their tools. So it may indicate that there's some more digging we could do in their tools to find out more information about them, like YAR rules or something else that we could do to detect the tool itself rather than just the use of the tool. But I wasn't too exactly happy with that value, those previous two visualizations, so I decided to combine them. If I have a heat map here that basically has both of those at the same time, and you have the attack lifecycle on the bottom and the pyramid of pain on the left. And both of these models are inherently ordered, which is important because it lets you know things like, this is a good section because it's at the top of the pyramid of pain. You would like to have more artifacts, tools, and TTPs. This is a good section because it's near the end of the attack lifecycle or the kill chain, so your information is inherently more valuable to you because the things that you're going to be able to detect and respond to are inherently more damaging to you at that level. And then this right here is the best because it's the overlap of those. But compare where we are with the good and the good and the best. We have some in each of those, so that's great. But the majority of our stuff is here on the bottom in the middle, right? It's hashes for delivery and exploitation. And by the way, combining these two gives you a lot better visibility into what you're actually collecting than even looking at the two heat maps individually did, because it jumps out like it's hashes in delivery and exploit. We also have some artifacts in the delivery section. That's our strengths. We have a few and some TTPs even in the best area, but we could do a little bit better there. But remember, I also wanted to answer some questions about the age of our intelligence. So what I did was I took all of the collected data. It says IOCs, but it's also IOCs plus TTPs. And I put them into a plot just to see how old that data was. I basically subtracted the day's date, and I said, you know, this thing is now 200 days old, rather than the actual date, right? And then I made this box plot. And if you're not familiar with reading box plots, the critical things to know are this is the location of the oldest data. So, I don't know, 500 days, something like that. This is the location of the newest data, which was pretty close to 0, so we must have just collected it when we exported. And this is the median, so exactly half of your data points would be above it and half below it. So and that whole shaded area in the middle is basically the middle half of your data. So looking at this, I can tell, for example, that the median is about 150 or 180 days old, so roughly 3 months. So we have pretty current data, but we do have data going back over a year and a half. So we also do have some historic data to be able to compare that to. So this is actually pretty decent. It's not the only way that this graph would look to be a pretty decent graph, but this graph is pretty decent. I also, just for fun, to see if it would show me anything useful, is I took a random sample of the IOCs that we had, and it's important that it needs to be random, and I plotted the actual dates, sorry, the days old, on the left, just to see if it would show me interesting things. And it does. It actually shows me the pattern of collection. It doesn't necessarily mean the amount of work we were spending. Maybe IOCs were not available. New IOCs were not available in the white areas. But maybe we didn't collect because we didn't feel like it or we forgot or something. I don't know. But we had some big gap here at the top, but we had a pretty relatively good pattern of repeated collection starting like a year ago. And you can see the banding. So you can actually kind of like see when the CTI team was able to collect more and when they were not. But as a repeatable pattern, you can see that they've basically been collecting on this adversary for a while now. And I did the same thing, broken down by the attack lifecycle just to see what it would tell me. I think, in general, this graph is okay. You can see like a lot of our exploit stuff trends older. The median is way, way higher. But we do have a lot more recent stuff. Most of our stuff is recent. So we have a lot of recent things, but we also have pretty good history there for how they do the exploit step. I think our command and control is probably darn near perfect because we have not quite a year of continual information about their command and control, but we have probably like 9 months or something like that. But a lot of it is very recent. It turns out a lot of the things that we had in the execute phase, like everything we had in the execute phase, was a undated behavior. So we had entries, but I couldn't plot them on the graph because there was no dates, so I didn't know how old they were. So there's a gap there, right? We did the same thing by the pyramid of pain level. The pyramid of pain level, I think, is a little bit even more important to do this with because the volatility implied by each of the layers shows you how important that is for that layer to be fresh. So like we have a lot of old hashes. An old hash is like the saddest thing in CTI. It is not useful for anybody, except if you're going to go digging through like the cyber paleoarchaeology stuff. But for detection and response purposes, it's not useful at all. But then again, we do have some fairly fresh data in like the domain names and stuff. And we even have this untracked category of other, where it was something that we were tracking and it didn't fall directly into the pyramid. So the lower the level, the closer you are on the left to this graph, the more new you would want your indicators to skew. And finally, this is actually a slide that I don't like, but I wanted to visualize all the things, and so the behaviors were all the things. I almost didn't show this one, but this is an extract from the attack navigator that the attack team puts out, where I took all of the TTPs that I had extracted, all the behaviors, and I mapped them, and I made a visualization. I don't know if you can extract very much good info out of this visualization because there's a couple things. One, in this part, in the matrix, Katie is absolutely right when she tells me nothing is more important than any other column, right? They're not ordered. So you can't say things on the right are better or things on the left are better. And you can't say things on the bottom or things on the top are better. They just are. Also, when you have colored things that you know, then you naturally have a lot of uncolored white things that you don't know, and you might be tempted to consider those gaps, but they're not, because this is a category of every possible thing that could happen or could be done, and we don't know that the threat actor does any of those white things. So they're not known unknowns, they're unknown unknowns. And you cannot really get too much out of this, except for, if you look closely here, you'll see there's one column. I know you can't read it. There's one column that I don't have anything for. Turns out that column is exfiltration. My threat actor probably wants the fruits of their labor. I'm pretty sure they know some way to do exfiltration. We just don't apparently know what it is. So we did find an insight from here. I don't really personally like this way. I don't know of a better way yet, but my CISO loved it. Some of the key challenges I wanted to talk about when we did this, I said the CTI data was in multiple repositories. So we ended up doing a lot of custom Python code to extract it. Each repository had its own module, and then I read a lot of data in English text and extracted it into Excel. We also had the inconsistencies in the data that was tracked by each repository, especially the ones that looked like they were the same but weren't. And because a lot of these were in-house developed tools, we didn't really have documentation on what all these things were, so it wasn't always obvious that I had a mismatch, and we kind of had to find some of these by accident before we could identify them all. But again, a lot of custom code, a lot of estimates and guessing were involved here to kind of convert this, but educated guessing. So, and then converting our one-time analysis to something that we could do on a regular basis is something that we still have ongoing. We haven't totally solved. We did all these things in a Python, an IPython or Jupyter notebook specifically so that we could do them again in the future. But because of the extreme manualness of a lot of the phases that we went through, we are not quite able to do that. It's something that we really want to do, and something that right now the Intel teams are digesting and kind of considering how they can make some changes to support this, because I think we realize that this is an important way that we can know if we're doing a good job that we couldn't know before. And we would like to do this on some regular basis, monthly, quarterly, or whatever, for our priority threat actors. Just to give us a snapshot of where we are, we can compare that snapshot to the past to see if we've improved, and we can look at that snapshot to see what we need to do in the future. So real quick, since I'm actually out of time, I'll go through my takeaways here. Start with identifying your key threat actors. This is a CTI summit, so maybe most of you probably know your key threat actors. Where is all that data stored? And make sure you know what data is stored, what it means. How to interpret that timestamp, for example, right? Expect to spend most of your time extracting, cleaning up, and deduplicating that data, unless you are in the fortunate spot of having everything all in one tip. And even then, you're going to have to clean, merge, and deduplicate. You just haven't figured it out yet. And pick your favorite attack lifecycle and pick the pyramid of pain. And map your IOCs and your TTPs to those. We didn't do those individually. We had data about classification, basically, of each one of those. So we mapped the classification of the IOCs to the pyramid, and therefore we're able to do it pretty easily en masse. And then visualize to identify the gaps, because that is, in fact, the point of this process. I will say we also extracted some numbers and tables of things, but really the visualizations were the key for us. And then automate it so that you can do it on a schedule and ad hoc, so that you can do this quarterly roll-up of how you're doing with all your threat actors that you care about the most. And anytime your CISO or anybody comes and says, I need to know how we're doing against this threat actor, you can tell them in 5 minutes rather than 5 weeks. And that's it.